For a TV, the world is thinking.
We need to worry about integration. And so if you think back to where I started about the compute integration, why we can all now have supercomputers in our pocket, or I can ship you a data center in a very large metal box. So this is sensor integration right now. And so fundamentally, this is a weather station at the South Pole. And you're looking at something that looks very similar to the first computer back in the 1940s. So it's measuring temperature, pressure, humidity, wind speed, how much light is falling on the device. It's about the size of a person. So research in the area has progressed to the point where in the middle is a commercially available project. It can measure about 5 different things, sound, vibration, temperature, and it's about the size of a deck of playing cards. And so this is analogous to the first personal computer. And Sense is about bringing this forward to really getting towards something that we envision 10 years from now as maybe the size of a pushpin, where you can measure all different modalities, not a specific sensor for the applications I've talked about, but one sensor that can measure all of these different things. Built into this is the processor, the storage, the radio to get the signal out, energy scavenging, and battery. But it's about this integration. So at HP Labs, the technologies we're working on to get to this point, we're working on a technology called Memristor, which is about building logic and memory to a size where the device is actually 10 nanometers across. Typical computer chips right now are running at the 60 nanometers, so we're already working on prototypes that are far beyond that. But we can build logic and storage. The smaller you get, the lower power it is, and the less it costs. Energy harvesting is very important to this. You have to power these autonomous devices. You can scavenge the vibrations of the bridge, or you can scavenge light that's falling on it from solar-type stuff. We have a really neat program in photovoltaics that integrates with these sensing technologies. Which gets me to in the upper right of the slide is the feel. So we've developed a new MEMS accelerometer. So this is the device that was originally done to do the collision detection in airbags, and now maybe you've experienced in a game controller that lets you simulate playing tennis or bowling. We've got about 1,000 times more sensitivity than that, which gets you away from simulating sporting events and into measuring the vibrations of like a bridge structure. And at the bottom is taste and smell, which is chemical and biological sensing. So we've concentrated on these areas of sensing because that's really what will bring this to the brain power. So we take a look at what you could do in a smart freeway setting. So if I take a freeway and I put my sensor node here with all of these variables I'm measuring, each of my green arrow along these freeways is where I could measure the light, the humidity, the airflow, the sound, the vibration, and the pressure. These raw numbers are coming in from the sensor. They're going wirelessly into a data center where they combine with what the data center has stored is the history. So not only do we know how fast the cars are going right now, we also know that at Friday at 5 p.m. today what they're doing and what they've done for the last Fridays for the last 6 months. And you start to combine that history together, and that data creates information. So as a cloud service, what you can do with that information is you can send it to a number of different consumers. So what we've noticed is at a particular spot on the freeway, the volume and the speed of the cars are down. And so you've got this highway patrol, which is a very precious resource that we want to allocate very carefully. Normally, if there's a problem on the freeway, the sensor for that is a 911 cell phone call. But in reality, there could be something in the freeway that if an officer could move before the accident happens, we could prevent that. So you've got volume down on the freeway. Nobody's called in yet. We've got an officer that's within a couple miles. Let's have him patrol by this area, and perhaps it's as simple as there's a plastic bag in the freeway that he can move out before the accident happens. That same information can go to the Department of Transportation, who's interested in figuring out where are the trouble spots in their infrastructure system. So what are the top 10 places in the Bay Area where we have these problems that are getting worse in traffic, so they can allocate this precious resource for improving it. Not only that, because we're measuring the volume of vehicles going by, we can target the places where we have the biggest impact on the largest number of users of this system. So automakers or wireless carriers may want to just simply provide traffic advice to their subscribers. How can I get you from point A to point B? All of this data that's coming off the system is really about helping you get to the places you need to go. And again, I said we've got this weather information in there, which could potentially be a mini weather station every 10 meters along the freeway. And so what you've got is the ability to study the microclimates in the Bay Area at a resolution that you've never been able to see before. So the same data coming off the sensor network has a lot of different uses. And this is just one example about how that can happen. So we call the vision sense, central nervous system for the Earth. It's about all these applications where if you can measure what's going on, you can sense what's happening, you can get at the heartbeat of the Earth, you can look at how things are moving, you can look at the climate, you can look at where the people are, what they are doing, what's going on. We can start to use this brain power to do something as simple as turn off the lights in a room where nobody is.